We'll see the next question. The question is, three equal circles are drawn on a triangle ABC with points A, B, C as the centers. Radius of each of the circle is equal to half of the side of the triangle ABC. Figure not to the scale. Angle ABC is given as 60 degree. Area of shaded region 1 is 128 1 by 3 centimeter square. Quantity 1, area of the shaded region 2, which is seen in the figure. Quantity 2 is 30 centimeter square. So this question is taken from RBI grade B. So we have to find quantity 1 and quantity 2 is given and check which is greater. So first I'll explain the question to you. So here we have a picture. So there is a triangle ABC and in the vertices three circles are drawn of equal radius. Radius of the circle is half of the side of the triangle. And we have to find this region 2, and by seeing this picture, so many will think that region 1 is greater than region 2, and obviously region 1 is greater. But what is our question? Question is quantity 1 is region 2 and quantity 2 is 30 centimeter square. So we have to check if region 2 is lesser than 30 or more than 30 or equal. And now we'll see the working. So how to work out? Region 1 value is given. So what is region 1 given? It is 128 1 by 3 centimeter square. So in the circle, a circle center angle is 360 and they have given for ABC angles are 60 degree. We can draw 6 such sectors in a circle. And for this 5 parts area is given. So we have to find area of the whole circle. By finding area of the circle, we can get radius of the circle. After getting radius of the circle, we can find side of the triangle, which is double the radius. And getting the area of the triangle and area of the sectors, subtracting, we'll get this region 2. So that is the working part. And instead of doing all this working, just I'll give you a simple logic, that is comparing areas of this triangle and the sector. And with that, easily you can get the answer. So now, we have an equilateral triangle. So because they have given angles of these vertices are 60 degree. So all same angles, which implies that all three sides are equal, and this is an equilateral triangle. From this we are going to remove 3 sectors. These 3 sectors, central angle is 60. Now when you add all the sectors, what will be angle of these 3 sectors together? 60 plus 60 plus 60 is 180 degree. For a circle, central angle is 360. But we are going to remove a sector whose central angle is 180. That is 3 sectors we are going to remove where central angle is 180, which is nothing but we are going to remove a semicircle from a triangle. Now I will compare the areas of equilateral triangle and the semicircle, and then we get the ratio of these areas. Then easily we can find the answer. What is area of the equilateral triangle? It is root 3 by 4 A square, where A is side of the equilateral triangle. And for a semicircle, for a circle area is pi r square, for a semicircle it is half. So now I'll write this radius in terms of this side of the triangle. If side of the triangle is A, radius is half its side. So instead of r, I'll take A by 2. So for an equilateral triangle, it is root 3 by 4 A square. For a circle, pi r square, it is A by 2 the whole square. For a semicircle, it is by 2. So root 3 by 4 A square. I'll write pi in terms of value of pi is 22 by 7 and A square by 4. Now cancelling all the common factors, A square, 4, and here we can cancel 11. So 7 into root 3 is to 11. So area of an equilateral triangle, if it is 7 root 3 parts, area of the semicircle which we are going to remove inside of a triangle is 11 parts. And we need, so 7 into root 3, just we'll multiply. What is value of root 3? It is 1.732 and multiplied it with 7. So which is approximately equal to 12. So we'll get 12.12. Just we don't need the actual value, so I'll take approximate value. 7 root 3 is approximately equal to 12 and area of the semicircle is 11 parts. We need the region of the area in between these circles, which means area in between the triangle and the sector. So what is difference in parts? 1 part. So we have arrived that area of a triangle, if it is approximately 12 parts, and area of these 3 sectors, that is the semicircle area, if it is 11 parts, in between area is 1 part. So we need 1 part which is region 2 and which is quantity 1. So we have arrived that what we need, that is quantity 1 is 1 part, but we don't know the absolute value of this. So what is quantity 2 given? So don't compare this region 1 and 2 for quantity 1 and 2. But quantity 1 is in between area 1 part. Quantity 2, they have given us an absolute value which is 30 centimeter square. Now we have to calculate this 1 part in terms of centimeter square. So how to find this value of 1 part? So that I'll tell you with the given data. So in the question they have given area of region 1 is value is 128 1 by 3 centimeter square. So with this we can calculate area of the semicircle which is 11 parts. After getting 11 parts we can easily find what is value of 1 part. So now in a circle, so with a sector angle 30, we can draw 6 such sectors and with central angle 60 degree. What is the data given? For this 5 sectors, area is given as 128 1 by 3. So converting this to improper fraction, multiplying and adding 128 into 3, it is 384 plus 1, it is 385 by 3. And what is the value we have got? 385 by 3 is this region 1 which constitutes 5 sectors. So 5 parts, we are dividing this circle into 6 parts. For 5 parts area is 385 by 3. How to get area of the full circle? We need 6 parts. So dividing this by 5, because 5 parts area is 385 by 3, dividing it with 5, we will get area of this 1 sector, 1 part. And multiplying this with 6, we get area of the full circle. But what we need only area of the semicircle, the half of the circle. So dividing it with 2. Now it is obvious that cancelling all this, 385 by 5 will be area of the semicircle which is equal to 11 parts. So dividing 385 by 5, we get 77. So as it is area, it is 77 centimeter square. So from the given data, that is they have given area of this 5 sectors as 128 1 by 3, and I have found area of 3 sectors which we need. 3 sectors area is area of a semicircle which we are going to remove from the equilateral triangle. So that is 11 parts. If 11 parts is 77, what will be 1 part value? Divide this 77 by 11. 1 part is 7 centimeter square. So friends, so seeing the picture, don't think that we are asked to compare region 1 and region 2. We are asked to compare this region 2 which we have calculated the value by comparing the area ratio, it is 12:11, and in between area, if we need difference in parts will be in between area, that is 1 part. The 1 part is calculated with the given data as 7 centimeter square, and that is our quantity 1. So now quantity 1, we have got as 7 centimeter square, and this has to be compared with quantity 2, so which is the absolute value which they have given us 30 centimeter square. So now according to our working, quantity 1, that is region 2, is smaller than quantity 2, which they have given as 30 centimeter square. So quantity 1 is lesser than quantity 2. Now the answer is option B, quantity 1 is less than quantity 2.